Welcome dear students. Now we are going to learn two very fundamental concepts of chemistry, that is calculation of oxidation state and the calculation of pH. In order to calculate the oxidation state of an element, we need to learn certain basic terms. Now let us learn about oxidation number. It is defined as a formal charge which an atom of that element appears to have when electrons are counted. Oxidation number of an atom may be positive or it can be negative. For example, the oxidation number of potassium and bromine in potassium bromide is +1 and -1 respectively. Now, let us see what does an oxidation reaction mean. Oxidation reaction is a reaction in which an atom or an ion loses one or more electrons and thus increases its oxidation state. Due to the loss of electrons, oxidation is also called as de-electronation. Example, magnesium plus oxygen gives magnesium oxide, where the oxidation state of magnesium from 0 changes to +2. Next, let us see what is a reduction reaction. A reduction reaction is a reaction in which an atom or ion gains one or more electrons and thus decreases its oxidation state. Due to gain of electrons, reduction is also called as electronation. For example, MgO plus carbon gives Mg plus CO. In this state, the oxidation state of Mg is +2. When it combines with carbon, it has become 0 oxidation state. A loss of electron has taken place. Next, let us see what is a redox reaction. The reaction in which gain or loss of electron takes place simultaneously is called a redox reaction. Example, zinc plus copper sulfate giving zinc sulfate plus copper. Here in this case, zinc has a 0 oxidation state, whereas carbon has a +2 oxidation state. At the completion of the reaction, zinc acquires a +2 oxidation state and copper becomes 0 oxidation state. And therefore, zinc has got oxidized and copper has got reduced. Therefore, it is a redox reaction. Next, we'll see what is an oxidizing agent. An oxidizing agent is that substance which oxidizes some other substance and is itself reduced to a lower oxidation state by gaining one or more electrons. Example, a metal plus electron gives negatively charged metal. So initially the oxidation state of the metal was 0, and after the reduction process, oxidizing process, it has become -1. It has gone to a lower oxidation state, whereby it has got reduced. Next, we'll see what is a reducing agent. A reducing agent is that substance which reduces some other substance and is itself oxidized to a higher oxidation state by losing one or more electrons. For example, a metal gives away one of its electrons and becomes oxidized, whereby it gets oxidized and it reduces some other substance. Now, we'll define oxidation and reduction in terms of oxidation state. The increase in oxidation number of an atom through a chemical reaction is known as an oxidation reaction. A decrease in oxidation number is known as a reduction. Such reactions involve the formal transfer of electrons, a net gain in electron being a reduction and the net loss of electron being an oxidation. Now let us calculate the oxidation states of various compounds. For example, let us take an example of an acid. Oxidation state of sulfur in sulfuric acid. Let us calculate. The oxidation number of hydrogen is +1 and oxygen is -2. Generally, hydrogen will always have a +1 oxidation state and oxygen will have a -2 oxidation state. Similarly, alkali metals will always have a +1 oxidation state. So for our calculation, we can take them as +1 and -2. Only in the case of hydride, the hydrogen will have a -1 oxidation state. Therefore, when I calculate what happens, there are two hydrogens, so it is 2 into 1 plus X is the one of that of sulfur and plus 4 into -2 that of oxygen. Addition of all, the summation of all comes to 0 because sulfuric acid doesn't have a formal charge. The compound as such doesn't have a formal charge, and therefore, so when calculating, X is +6. So the oxidation state of sulfur in sulfuric acid is +6. Let us take an example of a base now. The oxidation state of nitrogen in NH3, we can calculate. The oxidation number of hydrogen is +1 again. So it becomes very simple. X plus 3 into +1 is equal to 0. X plus 3 is equal to 0 and X is equal to -3. The oxidation state of nitrogen in NH3 is -3. Next compound, we will take an example of an oxidizing agent, KMnO4, potassium permanganate. We will find out the oxidation state of Mn, manganese, in potassium permanganate. Now since potassium is an alkali, its oxidation state is +1 and oxygen is -2. Put it in the calculation. 1 into 1 plus X plus 4 into -2 is equal to 0. So X plus 1 minus 8 is equal to 0, X minus 7 is equal to 0 and X is equal to +7. So the oxidation state of manganese in KMnO4 is +7. Let us now take an example of a reducing agent. The oxidation state of boron in the reducing agent, sodium borohydride. The oxidation state of sodium is +1, it's an alkali again, and hydrogen is -1. Remember, I told you in the case of hydrides alone, the oxidation state of hydrogen is -1, and therefore 1 into 1 plus X plus 4 into -1 is equal to 0. So 1 plus X minus 4 is equal to 0 and X minus 3 is equal to 0. Therefore, the oxidation state of boron in sodium borohydride is +3. So these are the practice problems. Calculate the oxidation state of phosphorus in H3PO3. Very simple. Just add on all the oxidation states, put for phosphorus as X and mathematically calculate. Next one, calculate the oxidation state of nitrogen in NH4OH. Similarly, you have to do. Calculate the oxidation state of chromium in K2Cr2O7. Here too, similarly, you have to do. Calculate the oxidation state of aluminium and lithium in lithium aluminium hydrate. Next, we'll move on to the OERs. So the Khan Academy OER is explanatory and you can watch the video once. Now we'll move on to the calculation of pH. How do we calculate the pH? pH is equal to, the formula of pH is minus log of H plus ion concentration. Similarly, pOH is minus log of OH minus ion concentration. Kw, that is the ionic product of water, is the product of the concentration of OH minus ion and then H plus ion And in water, we know that Kw is equal to 10 power minus 14. And therefore, the OH minus ion concentration is 10 power minus 7 and H plus ion concentration is 10 power minus 7. So Kw will be equal to, pKw will be equal to 14. P is nothing but minus log. So pH plus pOH is equal to 14, and we can calculate pH when we know pOH by just subtracting it from 14. Let us see an example. What is the pH of 0.001 mHCl? pH is equal to minus log H plus, we already know. Just have to substitute 0.001, the concentration of H plus ion, in the formula, and then find out the answer, which is 3 in this case. When we take the problems for practice, calculate a pH of 0.01 in H2SO4. It's so simple. But the thing is, it is not in molarity, it is in normality. So we have to convert the strength of sulfuric acid in molarity and then substitute in the formula. Calculate the H plus ion concentration of HCl whose pH is 3. Here in this case, the pH is given and the H plus ion concentration is asked. We just have to take a anti-log of the pH. Calculate the pH of 10 power minus 8 mHCl. In this case, we have to include the H plus ion concentration that is contributed by water molecule. Fourth problem, calculate the pOH of 0.01 m NaOH. It is very simple, direct substitution. And calculate the pH of 0.01 m NaOH. Here in this case, you have to find out the pOH of NaOH by directly substituting in the formula, and after which we have to subtract it from 14 in order to calculate the pH of NaOH. So this is the OER. Again, this is again from Khan Academy, and you can go through it. So today in this class we have seen how to calculate the oxidation state as well as the pH. Thank you.